All right, so last time I talked about the net change theorem and what the graph of the function, when we're given the rate of change function, what its graph means. And again, some of it's stuff we've already talked about in chapter 3. The new part is what the area represents, the net change in my area, which is my definite integral between points. And so now we're going to solve applications specifically where we're given the graph of the derivative, which represents the rate of change. And then I'm going to ask you a bunch of questions you should be able to answer using said graph. All right, so my graph here represents, all right, my a prime, my original function, which again, I don't have the original function. The original function would represent the number of people employed at a company between 2002 and 2014. That would be the statistical information we're using. All right, t represents the number of years after the beginning of 2002, so 2002 is where we're starting, so times 0. All right, up to 2014, which would be 10 years later. All right, we're given the derivative, right, which is number of people, all right, per year, number of employees per year. All right, that's what this derivative would represent. So this graph, my a prime of t, represents, which is the change in employees per year. All right, that's the rate of change we're given. All right, and then we're given areas of, again, information about it. All right, so remember, area above is a gain, area below is a loss. All right, so gains and losses. So based on the economy, over some years they'd be adding employees because they're booming and growing, and some years they'd be losing employees because the economy maybe is going bad, and they've had losses, and they've had to unemploy people, fire people. All right, and so this would be how it happened over the information over the years. All right, so this is the equation we're going to be using. All right, so the first question: during the 12-year period, between what years is the company losing employees? So losing employees mean this should be the negative areas, which is the area below the x-axis, or the t-axis in this case. All right, so if I go look at my function, that would be a loss, and that would be a loss. So this would be time 4, which would represent 2006. This would be time 8, which would represent 2010. And then time 10, which would represent 2012. And then 12 would be 2014. All right, so that's when we're losing. We're losing people over the years. So again, economy took a downturn, and they had to lay off. And so they lost employees between 2006 to 2010, 2012 to 2014. All right, so there's my answer to A. They lost employees over the years 2006 to 2010, and over the years 2012 up to 2014. All right, so that's the first question. And really, that one's not new, right? I'm adding people, I'm increasing, would be positive, would be above the x-axis. I'm losing, I'm decreasing, all right, and that would be below. And that actually is a question we answered way back in chapter 3. All right, at the beginning of what year during the 12-year period did the company have its lowest number of employees show work or explain? So there's two ways you could do this. You could show work using integrals, or I would also allow you to explain it. But you have to do one or the other if this is a question asked on a homework or a test question. And you need to at least explain how you got your answer, or show the work behind it. All right, so we want absolute minimum. All right, absolute minimum, which can only happen at endpoints or critical points, but specifically criticals that were relative minimums. All right, so if I go look at my graph, so I'm going to go back up to my graph. All right, my critical points were at 4, 8, 10, 12. My endpoints are 12 and 0. And I'm looking for the absolute minimum. Well, if I look at 0, if I kind of look at where the projection of this graph would be going, I would still be adding people up to 0. All right, so 0 wouldn't be a minimum. It could possibly be a maximum, although I doubt that it is because I'm adding people after it. And so 0 would not be included. It's not going to be a minimum because I'm gaining over the year 0. All right, then I look at my critical values. All right, so 4, I have a big gain up to 4. So 4 would be I would increase and then stop at 4. And so that would not be a max, that would be a minimum. Or sorry, that would not be a minimum, that would be a maximum. Said it backwards, guys. This would be a relative max. I'll write it down. Because I had a big gain before, right? Up, and then after that, I had a loss. And so this would be my relative min, right? Because I lost people, I had to lay people off over the years 4 to 8. All right, then we had a little gain. All right, which means that would be a relative max, right, because we gain. And then this endpoint would be a relative minimum, all right, and it could all be my absolute minimum because it's at the end. I lost employees right before I hit that 12, right, 2014. And so absolute min, well, my possibilities are at my relative minimum 8 could be, or so my minimum at 8 or my minimum at 12. All right, that's it. Those are the two possibilities. So the critical value 8 or the endpoint critical value 12. All right, those are my possible. They're both minimums. I just have to figure out which one's the most minimum, right? I'm looking for absolute. All right, those are my possibilities. And so what we do is, well, we find the net change. So I'm going to go write that down. That's going to be part of my explain. All right, so my possibilities are at the relative minimum time 8 or the end point time 12. All right, now I just have to figure out both of them are minimums because they're following a loss, laying people off. I have to figure out which one's the most minimum. And you could just do this as a description and showing your areas. I have to figure out what's the net loss up to those years. So in this case, I'm going to look for the net change from time 0 to 8. So I'm integrating from 0 to 8 of my derivative, finding that net change, and seeing if that's bigger or smaller than the net change all the way to the end, from 0 to 12. All right. Do I have I lost more people from 0 to 8, which would give me my absolute minimum, or did I lose more people as a net, all right, from 0 to 12? And again, it's a net loss and a net gain. It's over all of those years. When I get to the end of them, did I have more people at 12 or more people at 8? So I'm looking for minimums. Do I have less people at 8 years or less people at 12 years? And so I go add my positive and negative areas. All right, so keep in mind, remember, gain, loss, gain, loss. And so up to 8, I'm going to gain 202 employees, then lose 189. All right, and so to find this one, I'm going to gain 202 and lose 189. And so the net difference, all right, over all 8 years, I add, subtract, is 13. All right, we gained 13. All right, some of the years we lost, some of the years we gained. Total, over the 8-year period, we had 13 more people 8 years later than we did at 2020 when we started this. All right, well, let's see in 12 years if we have more or less than that to figure out which is my absolute minimum. All right, so I'm going to add all my areas up. So I add 202, subtract 189, add 56, subtract 50. All right, so I'm going to do all of those over here. And so to find this, I have 202 gained, then I lost 189, then I added 56 people back, but then I lost 50, and all together, if I add and subtract those, my net change in the number of people employed over that 10-year period, or sorry, 12-year period, was 19, was the net gain. So we had 19 more people at the end of 12 years than we did at the start. We had 13 more peoples at the end of 8 years than we did, and so this is smaller. And so this is the one I want. All right, so that means this would be the minimum amount of employees that we would have. So 8 years into the study, we reach our absolute minimum. All right, which would be the beginning of what year? I have to go back. So this is my minimum, my absolute minimum. And so it's 2010. All right, so 2010 is when they have the absolute lowest number of employees over this 12-year period, right? Again, just over this graph that I'm given. I don't know what happened before and I don't know what happened after, but from 2002 to 2014, the lowest number of employees that they had occurred in 2010, all right? Next question. At the beginning of what year during this 10-year period was the rate of change in the number of employees at its maximum? So this was just asking, when is the rate of change, right, which is my derivative, at its maximum? Again, it would be the absolute largest rate of change at its peak, right? Well, this is specifically the function I'm given, so I just look at my function and figure out when is the biggest slope. All right, the biggest slope occurs when a function hits the maximum, right? This is the rate of change function. The largest value my rate of change happens here. All right, and that looks to be around 2, which would be 2004. All right, and so 2004 would be my answer. Which would be time 2, but they asked me for what year. So 2004 would be when this company is growing really fast. They're adding the most employees that year, right? That's the biggest rate of growth for my employees. All right, next question. How does the number of employees in the company change from the beginning of 2006 to the beginning of 2012? So we're going from 2006 to 2012, and we want to know the net change. Well, that would be time 4, and that would be time 10, right? Time 10. And so we want to know the net change. All right, so we want to know, how does the employees change between the 4th year and the 10th year. Sorry, I did 12 instead of 10. All right, so between the 4th year and the 10th year of this study. And so we want to know what the net change is. And so what we're doing literally is finding the integral from 4 to 10 of our derivative, which again would be adding the positive area, subtracting the negative area. So I have to go back to my picture, and I'm only interested in between 2006 and 2012, so between 4 and 10, how did the company change? What was the net change in its employment? All right, so going back to my picture. So I'm looking between 2006 to 2012. All right, so between 2006 and 2012, they lost 189 employees, but then gained 56. And so the net change would be taking by loss 189 and adding 56 to it. So negative 189 lost, and then we gain 56. So the net change excuse me. Make sure I get it right. So I'm going to type it in. 189 minus 56, or plus 56, so 133, negative 133. All right, so there was a net loss. All right, so over the years, over those years, the company had a net loss of 133 employees. All right, over those 6 years. Now, it was really the first few years where they lost the employees and the last couple of years where they got to gain a few back. But over all of them, the net loss between the 4th year and the 10th year of the study was a loss of 133 employees. All right, and again, I did ask for the definite integral, and so this is what the definite integral is looking for. So this is what I'm looking for when I'm asking for it. So I want to see this. This is what you're solving. And then make sure you answer the question. All right, how does the number of employees change? All right, well, it changes by there was a loss. All right, they lost a lot of employees over those years. All right, they lost, we know exactly how many. They lost 133 altogether. Now, the first few years they lost 189, but then they got to hire 56 people back. All right, but it's, again, remember, it's a net change. All right, the next question. Suppose that we know that the company had exactly 2,200 employees at the beginning of 2004. All right, so 2004. Which would be time 2. Oh, I think this is supposed to be 2002. I forgot to change it on mine. I changed it on yours, so it should be on your notes and handout. But I forgot to change it on mine. Sorry about that, guys. But the one you printed off from Reginet, it should say 2002. When I went to plug it in here, I forgot to change that. So 2002 would be my beginning. 2002, that would be time 0. All right, so we know the company at time 0 had 2,200 employees at time 0. Find the number of employees the company had at the beginning of 2014. So 2014 would be at the end of this. This would be at time 12. All right, so we want to know how many employees they had at the end of the study. They started out with 2,200. That was how much they had in the initial year, 2002. All right, we want to know how many they have 12 years later. All right, when we hit 2014. And so, again, you can describe what's happening or show the integral. I'm going to go ahead and show the integral to explain what's happening. So, all right, first thing I'm going to find is the net change. All right, how much did the employees grow or decline over the 12 years? Which I'm using my derivative to do that, which I actually found that previously, right? That was one I did in the earlier answers. If you go look up here, all right, that's what happened here, right? Over the 12 years, they hired people, they fired people, they hired people, they fired people. At the end of the 12 years, they had 19 more people than they started with. All right, and so that's what this integral means. All right, so they gained 19 people. Well, I know there were 2,200 at the start. They gained 19 people. At the end, there should be 2,219 employees. They might not be the same 2,219 employees, because remember, again, we hired people and fired people at different times throughout the year. But at the end of 12 years, their total of employees, the net total, was a gain of 19, and so now they have 2,219 when they started with 2,200. Alright, the last one for this particular problem, I believe. Alright, evaluate, which means solve, and then explain what it means in terms of the application. Alright, so 0 to 4 of my derivative, which would mean that area at the beginning. The area at the beginning was there was a gain of 202 employees, right? The area at the beginning was 202. If I go back and look, I have to scroll all the way back. Alright, but right between 0 and 4, That's my area. All right, so we added 202 employees. But first, write it down. That's the evaluate, all right? All right, so that integral equals, the definite integral from 0 to 4 of my rate of change functions equals 202. That's the first part. And then the second part, what does it mean in terms of my application? Well, that means over the years, 2002 to 2006, the company added, gained, increased employees, however you want to word it, 202 new employees. All right, whatever they had, they now have 202 more. All right, so that finished up the first example. All right, hopefully you understood it. We'll do a second one just again solidify it. All right, so my second example, which I have to put my areas in because it didn't copy over. All right, so I've got this equation which represents the number of accidents per year at a particular region when the study was done, and the study was done from 1995 over a 10-year period to 1995 to 2005, right? That's when we would start. So time 0 would be 1995, time 10 would be 2005, right, when the study ends. All right, this is the number of automobile accidents as a rate of change, and I have to plug my areas in. That's 400, 1240, 410, and 390. It didn't cut and paste right. All right, so my critical values. Just to make a note of them, my critical values are at 2, 6, 8, and it looks like my endpoint 10 is also critical. All right, that looks like it hits 0 there. And then I've got gains and losses, so accidents were increasing or decreasing over the years. All right, so with this particular region, first couple of years, accidents were declining, and the next few years, they added a whole bunch more accidents and so on. All right, so this is a rate of change, derivative, rate of change in the number of automobile accidents in a city over a 10-year study. All right, use that graph to answer the following questions. All right, so the first question, oh, there's my, why they cut and paste where. All right, just ignore those. The number represents the area of the curve and the x-axis. All right, over what intervals was the accidents? And this one, you could just give the time intervals. You don't have to give the years. If you want to give the years, that's fine too. But it just says the time intervals, so you could just use the t values. And you could use interval notation, since it says over the interval, so I am going to use the interval notation. And so increasing would be my positive area, decreasing would be my negative area. So just go to my graph and figure out, well, when were accidents going up and when were accidents going down. Negative, positive, negative, positive. All right, so I'm increasing from 2 to 6 and 8 to 10. So over those years, so 2 to 6, 8 to 10. Which means I'm decreasing all of the other years, which would be from 0 to 2 and from 6 to 8. I'll go look at my graph to double check that is the case. But I was decreasing from 0 to 2 and 6 to 8. At the beginning of what year was the number of accidents at its lowest? So we want to know when we have the absolute minimum number of accidents. All right, so this is a lot like that one example we did in the last case. We want to know what the minimum is. Well, first thing I have to do is figure out where are all my possible minimums. My possible minimums, all right, so the possible minimums are either at critical values that are relative minimums, or endpoints following a minimum where I'm losing. All right, so I'm going to go look at my graph and figure out which of those cases I'm looking at. All right, so 0 is an endpoint. Now, it could be a minimum. However, what's happening after 0 is I'm still losing more people, so it's not going to be my absolute minimum. All right, so I'm going to throw 0 out because I was losing, so it is a minimum. I was losing before, but it's not an absolute because after 0, I've got this negative area, so I'm still losing it. All right, so I'm not going to include 0, but I am going to include 2. 2 is a relative min. Then we have a gain. This would be a relative max. Loss. This would be a relative min. And this would be a relative max. All right, so I'm not going to include the endpoint 10 either because it's gaining right before 10, and so that would be a possible maximum, not a minimum. So if I was looking for maximums, it would be 6 and 10 would be my possibles, but I'm not looking for maximums, I'm looking for minimums, so 2 and 8 are my possibles. All right, so I'm going to write those down. My possible minimums are at the critical values 2 or the critical value 8. One of those is the smallest, right? And I just have to figure out which one. All right, well, I find the area up to 2, so I find my number of accidents between 2 and 0. And compare it to the number of accidents at time 8. All right, so from 0 to 2, if I go look at my graph, from 0 to 2, I have a net loss, or loss is probably the wrong way to word this. Accidents decreased by 400. Oops. So negative 400. All right, so the accidents decreased by 400 from where they started. All right, well, let's see if that's higher or lower 8 years later. All right, so 8 years later, well, we've got to add up my area. So I know my first area is negative 400. Second area was positive 1,240. And then negative 410. All right, if you go look, I'll go double show you, right? Minus 400, add 1,240, and then minus 410. So just based on that, I'm going to guess this is going to come out a positive number. All right, and it does. It comes out 480. So in this case, accidents increased by 480. All right, so this would be my minimum, right? Negative. All right, a net loss is better than a net gain. All right, so this is my absolute, this is not, and so my absolute smallest number of accidents was in the year, right, the beginning of what year, so I need the year in this case, so time 0 is 1995, 2 years later would be 1997. So by the year 1997, accidents were at their lowest during this study. All right, they reached a minimum at that year. All right, everywhere else, every other year, they had more accidents. All right, that was at their lowest. All right, next question. At the beginning of the year, was the rate of change at its lowest? So we want to know when the accidents were decreasing, the number of accidents per year was decreasing the fastest, had the biggest rate of decrease, right? We want the biggest rate of decrease, or the biggest loss, biggest rate of change, biggest slope, biggest negative slope. All right, when is the number of accidents decreasing the fastest? And so the rate of change function is the one that we've gotten graphed, right? That's what the graph is. The graph is the rate of change function, right? That's what this is. This is the rate of change. And so we want to know when was the rate of change the smallest. The smallest would mean the most negative. It's moving down the fastest. Well, it's got a minimum there. This one looks lower than it. And so I would say this would be its lowest point, absolute maximum, minimum. All right, and it looks to me like it occurs at 7. All right, so 7, which would be 7 years after 1995, right? Which would be 2002. All right, by T7, which would be by 2002. All right, beginning of 2002. Right, it has the smallest rate of change. If I'm looking for the maximum, it looks like the maximum occurs at 4. I didn't ask for the maximum, though. I asked for the minimum. All right, the next one. How much did the number of automobile accidents in the city change over the 10-year period? So over the 10-year study, did the total number of accidents increase or decrease? All right, did they have more accidents by the end of the study per year? Again, it's a per year thing. Excuse me, than they did at the beginning. All right, so this is looking for the net change over the 10 years. So I'm looking for that difference. Number of accidents what we started with, number of accidents in the 10th year. What's the difference? All right, and so that's looking for that integral. All right, so we want to find that. And so it's just adding and subtracting all of my areas. So first the number of accidents went down, so negative 400. Then they went up, 1240. Then they went down. Then they went up. All right, so that's the positive areas above the curve, negative areas below. If you go look at it, and I'll show you the graph just in case you need to look at it. All right, number of accidents decreased by 400, then increased by 1,240, then decreased by 410, then increased by 390. All right, and you add and subtract all those increases and decreases. All right, when you do, you get the net difference from the year 0 to year 10, and so add, subtract. I believe that comes out to 820. So there was a net increase of 820 accidents. Right? Over the 10-year period. That was the net difference. Some years you had more, some years you had less. Overall, if you look at the net, gains and losses, moving up, moving down, that was the net change. All right, part E. If we know there were a total of 520 accidents at the beginning, so when they started the study, so the beginning of, 1997. All right, 2 years into the study, we know there are 520 accidents that they took into account by January 1st, 1997. All right, times 0. How many total accidents were in the city by the beginning of 1995, the beginning of the study? Where did they start? All right, well, I know 2 years in, 520 was how many accidents they took into account. We want to know at time 0, at the start of the study, how many accidents did they have. All right, so we want to find that. And again, you could describe it or show it. I'm going to show it using our integral notation because, again, it's sort of the way we want to look at it. And so I can find the change in the number of accidents between times 0 and times 2, which is the integration from 0 to 2 of my derivative. All right, which is that first area, remember, that went down by 400 accidents. Right, so I know 2 years in, it was 520. I'm looking for times 0. Move my 520 to the other side. And so there were 920 accidents that they took into account in the year 1995. All right, so at the beginning of their study, total number of accidents in 1995 were 920. Two years later, that dropped by 400, right? And so dropped by 400 puts me at 520. And so you kind of check to make sure your answer makes sense. You could just figure that out. You don't have to necessarily write all this out, although this would be the proper way to do it. You could just describe what's happening. I know that there were 400 less in 1997 than there were in 1995. And so add 400 to the 1997 to get me to 1995's, which when I add 400, it comes out to 920 accidents in 1995. Alright, we want to know how many there were at the beginning of 2003. And so that would be 8 years into the study. So we're looking for a number of accidents after 8 years. We know the number of accidents after 2 years. And I would use the one that we're given, not the one we found, just in case I made a mistake. I know 2 years into the study in 1997, there were 520. And so I'm going to use that information. So the first thing I'm going to figure out is, well, how much did we gain or lose in the number of accidents from the 2nd year to the 8th year? So I'm going to use my areas to do that. All right, so I'm going to add and subtract between 2 and 8. All right, so between 2 and